VLSos here. This is a video lesson for pre-algebra, scatterplot. And the way that I've written the word scatterplot here as one word, sometimes it's two, scatter and plot. I'd be lucky enough if I spelled it right. I tend to make it one word. A scatterplot is a graph. It's a type of graph. And it's the type of graph that you would make if you had data or measurements. Maybe from a survey or an experiment. And scatterplots that come from data means that you don't often have an equation that you'd be graphing. You're just going to be graphing the information that you have. So we want to make a note that very often you're making a scatterplot without having an equation to help you out or generate the data. Or else you'd make a graph of that equation instead. And scatterplots are often contextual. The data that we get comes from a real-world survey or real-world measurements. It has a real-world context, like word problems. And we are going to go through a process of making a scatterplot out of a simple and small data set. So we'll make an example. And the example will be a comparison of time measured in years and height measured in inches. We can organize data in a t-table. And because this information is a real-world measurement, then we're not going to use our typical x and y, but we'll make our t-table with t representing time in years and h representing height in inches. And this could be measuring the height of an individual. So when they're 1 year old, a little baby, it's 27 inches in height. And at 4 years, when time is 4, we might make a measurement of 40 inches. 10 years, 53 inches. 16 years, 59 inches. This is roughly the growth of a human being. I don't know how accurate it is, but it resembles the growth of a human reasonably well. I am purposefully not using graph paper this time to present this information. And graph paper is very useful for graphs. We're making a graph, a scatterplot. But I want to show that graphs can be made without the use of graph paper. The lines are helpful, but sometimes if a student might get the impression that graph paper is required or needed to make a graph. And I'm going to do it freehand and talk about ways to graph quickly and accurately when all you have is a blank space and a pencil. So not using graph paper is intentional. And the first thing that we're going to do when we make our graph, step number 1, is we're going to draw and label the axes. And we want to make sure to get in the habit of choosing descriptive variables. If this is a real-world situation, then we're going to get away from the abstract use of the typical x and y, and we've already done that. T stands for time because it represents a measure of time, and t is going to be the horizontal axis instead of x. H is a descriptive variable. H is describing height, or it's representing height, and that'll be our vertical axis. So we drew and we labeled the axes, and we chose descriptive variables, variables that represent what they stand for. The second thing that we're going to do is we're going to choose tick marks based on the data. And a little more specifically, we're going to look for and choose highest values first. This is an excellent habit when making a graph. And this is also where working with graph paper might lead one to make a choice that doesn't quite fit or help. It's easier to use this space, it's free of the lines. I'm going to look at my time values in my data, and I'm going to look for the highest value, that's 16 in this set. So on the time axis, when I put down my first tick mark, I know that 16 is going to be the largest value that I need to represent. So I'm going to go way down to the right, not all the way, but close to the end, and make a tick mark there and put my highest value. That helps because I can often see approximately what halfway in between my highest value and the origin would be. And this location, halfway, is going to be half of 16, or 8. And I can fairly quickly and accurately divide up my line into more tick marks and more labels. And this choice that I've made here for this axis is guaranteed to make the best presentation of my information. It's going to fit. I don't have to be surprised and try to plot something and have it way off or way too close and then have to adjust things later. I'm going to do that for the vertical axis as well. My highest value is 59, but I'm going to round that up to a 60 and put very high on the vertical axis for height, a tick mark, and label that one 60. Halfway down to the origin is then half of 60 or 30, and I could put some tick marks in there. That's probably 10 and 20, and I could add more later. I've labeled my axes, and now I'm ready to plot. And we have to make sure to not connect the lines with the points that we plot. So we're going to say, do not connect the points. And that's because the graph represents information, just these numbers. Doesn't represent an equation. We would connect points that we plotted if we were graphing an equation. This is different. So the graph represents data, not an equation. Plotting this, thinking of these as pairs, as an ordered pair. So we'd plot the point 127, 1 on the time axis and 27 on the height axis is approximately there. 4 on the time axis and 40 on the height axis is about there. And it might help to put in some tick marks for 40 and 50. Plotting the point 1053, if this is 8, this is where 12 is, and I could add some more numbers. 10 would be about here, and 53 is all the way up about here. A straight edge or a ruler can help with points that are in the distance, but I'm approximating them by eye. It's going to be fairly accurate, but not perfect. 1659 is the point right about there. So here I've completed a scatter plot. There's only 4 points on it. They're not connected. I didn't graph an equation. I just graphed those locations. Now, if this was a study or a mathematical survey or a scientific experiment, I might use this data and use this scatter plot and try to find a mathematical equation that fit perfectly the growth of a person over time. But this scatter plot represents my data. And it's called a scatter plot because it looks like these plotted points are scattered around.